Welcome to the Math Record. Today I'll be covering the second part of the ICTM Regional 2018 Division AA Freshman Sophomore 8%. I'll be covering questions 16 and 20. So in the previous video I forgot to give the answers, so here it is for all 20. And now let's begin with number 16. So 16 says n squared is equal to 28 factorial plus 29 factorial plus 30 factorial over 28 factorial. And n is positive, and we need to find the value of n. So what we could do is that we need to cancel out that 28 factorial. So let's have 28 factorial on the top, distribute it out. So that's 1. This is 29, and this is 30 times 29 over 28 factorial. Okay, so that gives us that n squared is equal to 1 plus 29 plus 30 times 29. And then from here is an easy question. Basically, what you could do is you could kind of simplify this and then find the perfect square. But another way I would like to do this is I see that 1 plus 29, so let's put that as 1 plus 29. And then from here, I'm going to split 30 to 1 plus 29, and then it's multiplied by that 29. And now we see we could distribute out our 1 plus 29 from both sides. I mean, from both terms. So we get 1 plus, so 1 plus 29 divided by 1 plus 29 is 1. And 1 plus 29 divided by times 29 divided by 1 plus 29 is just 29. So we see 1 plus 29 in both of them. So that means n is just one of them. So it's just 1 plus 29, which is 30. So that is our answer for number 16. So you really don't even have to simplify it. You just have to rewrite it in a different way. So it's not really a hard question, but it's pretty interesting. Now number 20. In the figure, O is between W and E. OW is 50 and OE is 10. And then basically the rest describes this intersection of these triangles to determine the length of OX. Okay, so now let's make a length. And let's say we have a triangle. So something like this. I'm not really drawing it to scale. And then we have some lengths. So I'm just drawing a general picture, so it doesn't have to always be that accurate. And then from here, all the way to down here. Okay, so now let's delete this extra length because we don't need it. Now we have this figure. And I'm going to go a little bit up. So given from the information from this paragraph-ish, we know that this is 50, this is 10. So basically, we're going to use something called Seve's theorem, which gives us concurrency within a triangle. And it basically tells us if I draw a general shape, call this A, B, C, D, E, and F for all 6 of these lengths, A divided by B times C divided by D times E over F is equal to 1. So that is true. So basically from there, we could label some of our values. So if I call this A, we could call this AX, and we call this B, we could call this BY. So 50 over 10 times A over AX times B over BY is equal to 1. Cancel our A's, cancel our B's, simplify to 5. So that means 5 over X times Y equals 1. So that gives us that 5 equals X times Y, and Y equals 5 over X. So the reason I did this is because I want to limit the amount of variables we have. So then I can put in here. So this side would be 5 times Y, B times Y, which is just B times 5 over X. Okay, so let's delete that. So that is B times 5 over X, or just 5B over X. And now we're going to have to find points for these 3 values. And basically, what you need to know is kind of like a physics concept. The mass here multiplied by the length is equal to the mass here multiplied by this length. And it works for all 3 of these triangles, so you have to balance them all out. So so usually what I like to start off is I just choose one point. It doesn't matter which of the 3. And then I'm going to look at the opposite lines, so it's this or this. Or if you choose this point, you're going to choose these 2 points. And if you choose this one, you're going to choose these 2. So basically, I chose this point, so I'm going to use these 2. And then you're going to and then you're going to multiply these 2 values again together, and then that's 10 times b. And now we just need a balance. So 10b times 50 And then we have a 10 and this 10, so this side just needs a 50 and that b. And that's basically all you have to do. So we have 50b and an a, and this is an ax, so there we have a's. So this one also needs a 50 and a b, but needs to get rid of that x. So this is 50b over x. So when you multiply them together, they kind of match. And now we can look at this one. So this is 5 times 10, which is 50b squared over x. 50b, this b and this b makes b squared over x. So all of them are balanced. And now what we could do is, now I found these. So what we could do now is basically could find these 3 points, which they all work the same way. But I'm just gonna focus the one on the bottom. So basically what this is also another mass. So how do you find that mass? Well, basically you just add these two together from the end. So 10b plus 50b is 60b. 60, okay, it's kind of hard to see. 60b. Actually, I'll just write it inside. So 60b for this point right here. And you can do the same thing here. So this point would just be 50b plus 50b over x. And this point over here would be 50b over x plus 10b. But we really don't need it. So that is just for this. So we need to find this length right here. So let's label this L. And we have another point right here. So how are we supposed to find this length? Well, basically, instead of thinking this as one triangle, let's think about another triangle. So let's connect this point. Oh, sorry, I forgot to use a line. Let's connect this point to this point. And then I'm going to redefine our triangle. So we're going to have so let's connect this point back to this point, and this point back to this point. Okay, and now we need to find our lines of congruency, because in this original triangle, we have this line, and we have this line, and we have this line. And they made a line of congruency right here, right? So they made a line of congruency right here. So we basically need to find another line of congruency using these triangles, using this new triangle. So what we could do is, I know this line already connects from here to here. And I know this line over here connects here to here. So that means the last line that connects it is right here. So it's this one. Okay, so that gives us another point of congruency right here. So now we know that basically the mass at a point multiplied by its length is equal to the other point, its mass multiplied by its length. So we need to find this mass right here. So let's look for its intersection. Well, this intersection is right here. Okay, so basically remember the sum of the endpoints of those mass equals the middle. So a 10b plus this point as mass is equal to 50b. So that gives us that this one is 40b. And now we could do some math. So 50 plus 10 is 60. So the length times its mass, which is 10b, is equal to this length, which is L, times this mass, which is 40b. And now to get this length, just divide both sides by 40b. So that cancels this out. And our length, divide by this, divide by our 10. So 60 divided by 4 is 15 is equal to our length. And now if we want to find this entire length, it's just 10 plus L. So 10 plus L, which is 15, which is equal to 25, is our answer for 20. So it just takes a little bit of imagination working with lines of concurrency. And that basically covers our two questions. Thanks for watching, and I'll see you at the next math record.